Car is traveling from rest to 70 kilometers per hour in 30 seconds. Maintain a constant speed for 60 seconds, then decelerates to rest in 60 seconds. What is the total distance covered? So today we're going to cover kinematics. Kinematics is the study of motion. So when you want to know a certain distance, certain velocity, a certain acceleration, or a certain time, then kinematics is the way you want to solve it. So if we look at this, let's highlight our points. So a car is traveling from rest to 70 kilometers per hour in 30 seconds. Maintains a constant speed for 60 seconds, then decelerates to rest in 60 seconds. So there's two ways you can solve this. One, you can do the calculations. So we'll do both methods in this video. So we'll do both. We'll first cover this first section here. So this is what we want to find out first. A car is traveling from rest to 70 kilometers per hour. Notice this is in 70 kilometers per hour. Kilometers meaning 1,000 meters, and hours, which is 3,600 seconds. So if we look at our equation here, both initial velocity and final velocity is in meters per second. So we need to convert this kilometers per hour into meters per second. So we're going to use the conversion method. So let's say 70 and write kilometers up top and hours down bottom. Times. We know that there is 1,000 meters in 1 kilometer. And we know there is 1 hour in 3,600 seconds. So I'll write this R. So when we times kilometers, we've got kilometer down here, so this cancels out. We have hour down here, we have hour up here, so this cancels out. Mind you, when you have to convert from 70 kilometers per hour, the 1,000 meters should be on top, and the meters should be on top, and the seconds should be down bottom, because meters is up top, seconds is down bottom. So now it's 70 times 1,000 times 1 over 3,600. So put this in our calculator, 70,000 times 1 over 3,600, which gives us 19.44 meters per second. You can also write meters per second as meters per second. So now we have our final velocity. So this is our final velocity. This is our final velocity because it says the car is traveling from rest. So when it says starts with traveling from rest, our initial velocity will equal to 0 because we're starting from rest. Initial means starting from. Final is what you finish in the equation. So we have our initial velocity, which equals 0. We have our final velocity, which equals 19.44 meters per second. And we have our time, which is 30 seconds. So let's look at our equations here. So we have final velocity, we have initial velocity, and we have time. So, and we're trying to find distance, remember? What is the total distance? What is the total distance? So, we're trying to find distance. We have our final velocity, we have our initial velocity, and we have our time. So the second equation we will use. So D equals VF plus VI over 2 times time. So let's substitute. Distance equals final velocity 19.44 plus our our final velocity is 19.44. Our initial velocity is 0 divided by 2 times 30 seconds. So our distance for our acceleration will be, let me just put this in my calculator. $291.6 meters. Now, when you get a decimal, it'd be best not to change or not to. Sorry. It'd be best not to round up or round down, because this can also be centimeters, and it might lose you marks depending on how significant the rounding is. So let's call that D1, because this is the first question of the this is the first of the question or the problem. Now we come to our second one. So we have our time, but we're traveling at a constant speed. So if we look, our initial velocity will be the same as our final velocity in the first equation. So let's call this D1. Now we're trying to find D2. So what do we have? We have 60 seconds and we have a constant speed. So VI equals 19.44 meters per second. And our time is 60 seconds. So this is what we're working with at the moment. Now, if we look, it'll be hard to find a proper equation that we could use, because we don't have our final velocity and we don't have our acceleration. So what if we use the same equation, but our final velocity will be 0? Because we have the same, our final velocity and our initial velocity are the same. So let's try that. So let's use the same equation. Our final velocity, 0, plus 19.44 divided by 2 times 60 seconds. D2, put this in our calculator. So that comes to 583.2 meters. Now, it's unsure. I'm unsure if that would be the answer, because our final velocity would also equal the same. So let's just say the final velocity is the same as the initial velocity, because if the final velocity is 0, that means it indicates there is a deceleration, and we're not at that stage yet. So if we go 19.44 meters per second, let's try that equation again. So d squared equals final velocity 19.44 plus 19.44, our initial velocity, divided by 2 times 60. So that means our distance so our distance will be 1,166.4. That's a lot better, because it's 60 seconds. If it was 30 seconds, it would be half of that. So let's get on to our third distance. So let's find what we're needing to use. So we have, let's go to our third one. So our third one is this one here. So then decelerates to rest in 60 seconds. So this is where our final velocity will equal 0, because we are decelerating to 0. And our initial velocity will equal 19.44. And our time will equal 60 seconds. So let's just keep on using this one, because we have nothing other than our initial, our final, and our time. So plug in our final, 0, plus our initial, 19.44, divided by 2 times 60 seconds. So it'll be half of our second distance. So if we go 1,166.4 divided by 2 equals 583.2. Because we only have 19.44, whereas in this case we had 38.88 divided by 2 times 60. Now we only have 19.44 divided by 2 times 60, which will be half of distance 2. So 583.2 meters. Now we can find our total distance. So let's say d total equals d1 plus d2 plus d3, which equals, so what's our d1? Our d1 is 291.6 plus our d2 is 1,166.4 meters, and our d3 is 583. 0.4 to 0.2, sorry, 0.2 meters. So our total distance will be 2041.2 meters. Or 2 point, let's just say 2.04 kilometers. So that is our distance. So there are two ways of finding it. There's another way. We're going to use velocity versus time graphs. I'll just draw this graph. So let's call this 19.44. And let's call this, let's say this is 30 seconds. This is 90 seconds. And this is 150 seconds. Because remember, we accelerated in 30 seconds. We kept a constant speed for 60 seconds. 30 plus 60 equals 90. And then we decelerated for 60 seconds. 90 plus 60 equals 150. So this is our initial velocity. So, oh, sorry, that is our speed we maintain the whole time. So if we grab our red pen, draw a dotted line until we get up to our point of interest. So that should be about there. So this point here is where our line should be. And remember, we maintain a constant velocity of for 60 seconds. So if we draw a dotted line up to our point, this graph is not to scale, so that when you're in an exam, it would help to draw your graphs to scale, just so you know exactly what it should look like. It does help in exams, but it might take a little longer to draw it neatly. But this way is just as efficient as calculating it. So we have our points. So let's draw our gradients. So if we measure from 0, let's label this 0. Oh. Label this 0. So we want to measure from 0 to our point. So it's about there. About there. So that's where we are. We have our second point. and our third point. So this is what our graph should look like. It should look like a very, very narrow trapezium. So in order to find our distance, we measure the areas inside of these shapes. So this will be area 1, area 2. Actually, we'll call them D1, D2, and D3. So let's do our equations. So D1 equals the area of a triangle, which equals half base times height, which equals, so this is our base and this is our height. So half of base, so we have 15 times 19.44. Put that in the calculator. Which equals 291.6 meters. So D2 equals area of a rectangle, which is just base times height, which equals 60 seconds times 19.44. Which equals 60 times 19.44, 1166.4. And now D3 equals area of a triangle, half base times height. So half of 60, 30 times 19.44 equals 583.2. Total distance equals D1 plus D2 plus D3. D1 equals 291.6 plus 1166.4 plus 583.2, which gives us a total of, I won't calculate it because we already have it here, 2041.2. So if you ever come into an equation where you have to measure a total distance, just remember the distance is the area. If you have to measure the velocity is, or the initial, actually, another good pointer would be, so I'll draw it here. Remember this and this. So let's draw a middle line. So up here, this is VF plus VI. Oh, VI. Down here, this is VF minus VI. So, and acceleration is your gradient, G. So that's it for kinematics, and I hope you do well for your test.